Hello and welcome to the latest Leader webinar, JPEG XS New Kid on the ST21 block. But is it the right stuff? I'm Cindy Zulsdorf and joining Kevin and Steve from Leader and Kevin Hine from Grass Valley. Kevin, Steve, Kevin, say hello.
Hello.
Hello, everybody.
Yeah, and also from my side. A nice hello to everyone.
JPEG XS is the latest SMPTE standard, ST2110-22, to be added to the SMPTE 2110 suite of standards. Unlike ST2110-20, which is an uncompressed video standard, JPEG XS is the first compressed video standard. Why do we need a compressed video standard, and what implications does this have to your productions? In the next 45 to 50 minutes, Kevin, Steve, Kevin will discuss JPEG XS, what it is, and how it's being used in production. So without further delay, let me hand it over to Kevin. And don't forget, we'll be taking your questions, so please use the chat feature in Zoom. Kevin, over to you.
Thank you very much, Cindy. And Steve, it's great to be here again, and thank you for taking time out of your NAB schedule to join us for this session.
It's great to be here, Kevin. And thank you very much. I appreciate that. And everything going on. Kevin Hine, how are you?
Well, I'm super excited to be invited by the two of you. So, you know, we've got two of the brains of measurement and 2110 and all this kind of things, and baseband. Don't forget about baseband and other stuff. So I'm super excited. So thank you very much for the invitation.
Thank you for joining us. So Kevin, for those who don't know you, and probably even less who don't know who Grass Valley are, do you want to give everybody a quick introduction to yourself and Grass Valley?
Well, I hope that the vast majority of attendees today don't really need an explanation on who Grass Valley actually is. Well, Grass Valley is a company actually started the invention of a DA back in a little town called Grass Valley back in 1956, I think it was. But the company Grass Valley today is much more. Is actually grown from many different companies all together right now. We producing everything which is necessary to do live and sports entertainment shows, any sort of live production, any sort of post-production kind of thing, all the way from cameras, switches, infrastructure, editing, playout, end to end, you could say. And about myself, I'm working within this company for almost 20 years right now. I started as a service engineer back in the days in the Cologne area. I was not actually aware that Cologne, the city of Cologne, actually goes from the Brittany all the way to the Chinese border and from Stockholm all the way to Melbourne. So it's a rather big city. Working in service for many years, and then actually joined the dark side, the bright side, the sales team, to actually being a camera expert. You can call me nerd, camera guru, some people say. And ever since, I'm actually trying to express why we think that we do have a very good camera for live and entertainment productions, news productions, studio productions, all sorts of live and entertainment stuff.
Outstanding.
Thank you for that introduction. So let's get started. So as video consumption increases and content providers move towards higher quality content, bandwidth capacities become even more important. Broadcasters transitioning from serial digital interface, or SDI as you and I know it, infrastructure to IP technologies for uncompressed video transports within the broadcast facility have been using SMPTE 2110 and 2022-6. The IP environment offers bandwidth savings, decreased operational costs, and a common data center model for operation. However, a single-step transition approach from SDI to IP is not feasible for most broadcasters. So that means that SDI and IP are going to coexist for some time into the future. And as content providers push towards 4K resolution, and in some cases 8K, growing bandwidth requirements put more stress on the current infrastructures. SMPTE 2110 launched with only support for uncompressed active video, that's 2110-20, as that's how SDI had handled video. But very quickly, broadcasters started to look for alternatives that feature compressed algorithms. Whereas other codecs like JPEG XS and MPEG primarily focus on the compression efficiency, they disregard latency or the complexity. And that's where JPEG XS is targeting. How can we ultimately replace compressed video? So before we go any further, let's get the audience involved. We've got a first poll question. So Kimberly, Catherine, if you're able to pop that up, let's see how people are using JPEG XS today. So hopefully you can all see on the screen the question, and it's quite simple. How are you using JPEG XS today? So, Kevin and Steve.
Yes.
I was waiting to see how this one panned out.
Yes, likewise. So let's take a peek at the results.
Yeah. So we have as the largest contingent at 76% not currently using JPEG XS. So hopefully in the next 40 minutes or so, we can give you some snippets and things to take away so that when you do hit that first JPEG XS production, basically you've got nothing to worry about. So then interestingly, the next one, outside broadcast. Kevin, is that what you sort of expect at the moment with JPEG XS?
Well, frankly speaking, I would actually say I would tick all three boxes. So indeed, outside broadcasting, so when we talk about remote production, high quality distribution of content, JPEG XS obviously is the choice to go because of latency, etc. We're coming into these kind of things later on again. But we also see a trend in studio productions where people actually think, okay, we've done the exercise of uncompressed, but now let's make it more, you know, approachable when it comes to money, when it comes to bandwidth requirements. And obviously, cloud production services is another thing where a lot of people, when quality and latency is a subject, JPEG XS is the way, or one of the best ways going forward.
Excellent. Well, let's bring up question number 2, because it sort of goes hand in hand with this. So we know who's using it, and we know who's not using it. Let's see how frequently people are using it. So here we go. How frequently are you using JPEG XS? And I think we know which one's going to be the winner.
Yes.
So that's quite an interesting breakdown now. So those who are using it, the majority are using it on a daily basis, which is good to hear. Steve, any comments on that?
Not really. I think it's the daily basis is a little bit of a surprise. I like it because a lot of it's used for live sports. So that wouldn't kind of fall into that one, but for transmission, it's an excellent choice.
Excellent. So, Steve, I'm going to throw this question to you because I know your background is in the world of compressed video and that. Why has the broadcast industry, especially with SDI video, sort of continue to shy away from using compressed video? Because I've been in this industry for a number of years now, and it's always been uncompressed. And 2110 came along and has really reinforced that until JPEG XS appeared.
Yeah, I think it's always been a fear of you don't mess with my video. You don't do anything to the video. The second piece is on programming. Delays can just kill you if they are unpredictable or they're too long. And most of the compression systems from MPEG-2, H.264, H.265 all have multi-frame delays. And that really, when you're in a live environment or any type of environment where you've got things like news or even live sports, can really get in the way of things and really mess things up. It's also just the quality of the video and what goes on. I've got a little chart here I'd like to throw up on the screen. And one of the beautiful things about this happens to be, if you look at the yellow in the middle here, you can see that H.264, actually, HEVC, H.264, 265, and then back to MPEG-2, it was really built on compression ratios, getting the compression down, and they didn't really care how much latency was being thrown into things. And there was some artifacts that could come in due to the type of coding and the interframe statistics that could be used. Then we came up with JPEG 2000, but it's still an interframe coding, and the latency was better, but wasn't great. The quality could be outstanding. Either HEVC Intra, which is lossless, and JPEG 2000, which is visually lossless, worked quite well, but the complexity was pretty high, and the latency was still there. And now if you look at the outside circle here, we get into JPEG XS, and on the JPEG XS, you can see it pretty well ticks all the boxes, and the latency is phenomenally low. I urge you, if you're coming to NAB, stop by our booth, because we'll actually have a live camera from Grass running and have the SDI and the 2110 out of it, as well as the JPEG XS. We'll also have a path that is being started as SDI, getting converted to 2110, the 2110 getting converted to JPEG XS on our waveform monitor right next to each other. And it is incredibly low latency. You see a scene change, and it's like everything on the scene changes at almost exactly the same time. The latency is phenomenally low, and it's visually lossless. You cannot see the difference. And you can take it down to absolute lossless if you want to take the bandwidth up a little higher. Now, you don't get the bandwidth that you get out of some of the MPEG type control, but for distribution of content and keeping with contribution content quality, it is phenomenally good.
I think one of the important things here is to distinguish between distribution and actually creation of content. So back in the days, I'm coming from the camera manufacturing side, and one of the ultimate goals was totally visible, lossless, and ideally uncompressed signal distribution until end of our products. And when this UHD thing came along, so higher resolution, literally no one was capable anymore to do an uncompressed signal distribution right from the camera in the beginning. Yes, we do have higher bandwidth available right now, but back in the days, we needed to actually look into exactly the same thing like what you're saying here, but really the most important thing was lowest latency and highest quality. Because if you have 20 cameras around a pitch and you actually need to shade all of this or rack all of these cameras, they need to behave, and for the director, they need to be all in time and all in sync. So once this is all done, and you're talking about the program output at the very end, then actually a higher compression scheme with a longer latency is kind of acceptable depending on what type of production you do. I remember back in 2010 when the World Cup was ongoing, some people with a analog transmission actually hear the goal and the guy is cheering already, while on the digital transmission chain, they still see the ball flying towards the goal. So that back in the days, that was really like one of the arguments. So that's one is production side, the other one is actually distribution side. And we see a shift right now. So since the thing what happens in 2020 called COVID, I think each and every one of us was affected by this. Remote production really became one of the driving factors when it comes to high quality, low latency distribution. And that is actually, yes, one argument is we still have not enough bandwidth. And to every country I'm traveling is like, oh, you over there, you have a wonderful developed fiber distribution, but over here in our country, it is not so well developed. And the same challenge we have with almost every technology. 5 years ago, we were scratching our head and how should we actually do it? And 5 years later, we are, do you remember we discussed about, we want to produce a 4K signal over an HD signal. How should we do this? Is this impossible? So all of these kind of things are coming together. And one of the interesting factors we see even in studio environments these days is that customers are kind of tend to say, okay, we tick the box of producing uncompressed signals from a camera through an entire IP distribution and creation chain. But where are we going with this uncompressed content? It's not going anywhere uncompressed. And JPEG XS, and that's what you actually said, Steve, is visible lossless. And it has another advantage, it's actually not degrading in quality. I mean, after the 10 compression decompression cycle, yes, you will actually start seeing something. But one of the arguments of early compression schemes was you damage your source, you damage your master, and it's degrading substantially very, very quickly. Those kind of challenges for JPEG XS, at least, I can talk about JPEG XS. And in fact, it's interesting to see we within Grass Valley, when we had our, so the cameras there, when we actually sent signals from the cameras to our XCUs, our CCUs within Grass Valley, all of our cameras since 2012, 13 are IP-based cameras, and the majority of our customers are not aware. And what we're using in some of those is actually TICO, which is the predecessor of JPEG XS in a 4:1 compression. So some people say, oh, it's compression. But when we look into the compression levels, and I think that's one of the slides we will talk about, that actually JPEG XS and into PXS 10:1 is visible lossless. So 4:1 is absolutely perfectly fine. You will not see any problem, but you have a drastic improvement on bandwidth requirements.
Exactly. And I think the other big thing you mentioned there, Kevin, is the ability to compress, decompress, and recompress JPEG XS much better than virtually any of the other compression schemes out there. When you can do it in 10 different hops and not be able to see that it's ever been touched and still have subframe latency with 10 hops, it's phenomenal. The other thing is low complexity. You can add it to, manufacturers can add it to their existing products, and there's enough room in almost everybody's FPGA to stuff it in the corner. I mean, it's phenomenal. I mean, Leader, we have it in our waveform monitor, and we were able to put it on the existing FPGA. And it's just an option for us. And we turned that little piece on, and we didn't have to redesign the product.
And it works like a charm, I can tell you.
Oh boy, does it. Yes. And you've used it many times.
Yes, I did. A couple of times, yeah. Yeah, like you actually said, the one of our drivers was from the very beginning is to understand how the market is changing. And we've got plenty of different products in our portfolio. And I think one of the most important ones is going all into software-based solutions, which is AMP. And I don't want to go into that in particular, but over here, JPEG XS also makes a lot of sense because we get highest quality with low bandwidth requirements into a software-based solution. And next to this, we decided from the very beginning to put it into the camera. So it's part of the camera itself. It's not an additional box which needs to be configured, etc., etc. So it's like on your leader product, it's a license on our cameras. You just tick the box, it's switched on, it's easy configured, it behaves like a normal regular IP stream. Off you go.
I think this is one of the great things. We've sort of seen this with IP 2110 for those who've gone through the dash 21 piece about, you know, narrow senders, narrow receivers and stuff like that. At least with that stat, we had the foresight to look that this world is moving to a software based. It's moving away from proprietary hardware. And, you know, that extends the life of these products as well, because that's obviously one of the big fears, that we're not data centers where you've got your tier one customer and then you put in the next tier one storage. And if they won't pay the rate card for it, they drop down to tier two and tier three. Everybody in our game is treated the same. They have the same requirements. It's frame accurate leaving the camera. It's frame accurate arriving in the consumer's home. So we don't sort of have that step tier that we can push people down and say, well, you can have the program half hour after it was broadcast because you're now on an inferior system. So I think that's quite an interesting point, that, you know, JPEG XS is allowing us to move more to this software rather than, you know, proprietary hardware. So we touched on it there, and it's a question I frequently get asked on this. Okay, it is compressed, but what level of compression should I be using? Kevin, you must get asked the same question, Kevin.
Literally every single time, it's the same kind of conversation. There has been multiple tests done by many different bodies. People from EBU actually joined their heads together to discuss on this subject. We've been involved with a couple of tests with B-Sky-B, and plenty of others out there. As a rule of thumb, you can say in a UHD environment, a 11:1 compression is on the edge, 10:1 is perfectly fine. So a UHD signal, for instance, which is about 9 gig of data in 50 or 10.7 in 60 Hertz mode, is coming down to 1.1 gig in 60 or in 920 megabits per second in 50 Hertz mode. And interlaced formats are more challenging. I think you should not go beyond 6, probably 7:1, and 1080p is about 8:1. I think that's roughly. And if you do have a 65-inch screen and you stick your nose right on the screen, you can still try to find any problems, because the beauty of it, it's a wavelet-based compression. So the first thing you will discover, it is actually losing some of the high frequency stuff. So that's one other very important aspect of this whole subject compared to an MPEG compression.
Yeah,
right?
because
Where you see blocks, etc.
Yes, sorry. MPEG, the first thing gets thrown away is high frequency content, because that's how the compression engine basically saves itself, is it starts throwing away high frequency content and you start losing detail. And wavelet doesn't show up that way. And wavelet, since it's not interframe, you're also not going to get cascaded errors for the length of the gap.
Yeah. And one of this additional beauties of this whole thing is that it can be tweaked to be extremely low latency in this combination. So yes, you do have a compression scheme, you do have a compression ratio, and on top of this, we're talking about 16, 17 lines for compression decompression cycle. Yeah.
That's phenomenal. To be able to do compression decompression in a very small handful of lines. It
Yeah.
just blows me away.
So there has been, and I don't want to derail ourselves, there are some conversations more going into a higher bandwidth challenges when you really need to have very low data signals. So then you go into H.265. The biggest drawback, in fact, is the quality versus latency challenge you have. So if you want to have a good picture, you need to live with, yeah, how much? 60, 80, 100 milliseconds, if even, and then you are actually on the good side, timing-wise or latency-wise. And that is actually a no-brainer in JPEG XS, because in that time frame, yeah, you see the whole production is already done. While on the other one, the signal is still in the compression cycle to get transmitted, right? Yeah.
So as I said, Steve, you've already alluded to this on the leader products, that we can basically give you the tools that you're used to in SDI video, so picture, waveform, vector of a JPEG XS stream. One of the other things some customers have been asking, okay, so Kevin, you've just said what the compression is that we're going to, for the production. But obviously that is going to go through a chain of a load of third-party equipments over networks and stuff like that.
Yes.
And one of the things we're hearing is that not everything in the chain actually can handle that level of compression. And so one of the things we've added on the leader products is also a test pattern generator that you can vary the bits per pixel. So you can sit in a facility, send that signal out and check that it survived the journey, to the vendor. Yeah. And also in there, we can also, Steve, analyze what that bits per pixel ratio is that the signal's coming in at. So if we've got somebody who's deciding that maybe they want to, should we say, save some money by cutting down or compressing it slightly harder, you can shout and scream at them and say, hold on a minute, what I'm receiving is outside of the, the deliverable for the production.
Yep. You make sure that it's consistent from all sources.
So these are the sort of tools that, now you've got that flexibility. It's something you've also got to monitor and something you've got to be aware of, throughout your system, because, we're going through a lot of third-party products now.
Yep.
Well,
and the beauty of being able to put the signals on the waveform monitor next to each other, if they did start life in some other format, if it was either SDI or 2110 and then went through a gateway to XS, or just be able to look at the camera. Kevin, your cameras still put out JPEG XS. They'll still put out other signals. They'll put out uncompressed signals simultaneously, and you can pull them up on the waveform monitor next to each other and look at them. And I would take anybody to task and tell me which one's which, even on compression. I mean, you do something and it's simultaneously, when it's only 17 lines on the screen, you can't see the difference between the two videos when they're moving or doing anything.
No, so 17 lines, you will definitely not tell.
Yeah.
I think there is, we are on a journey with this whole story. So remember I said in our cameras, we actually started quite early by using Intopix Tico compression. Even before that, for some of the specific wireless applications, we already use JPEG 2000 compression, and JPEG 2000 is actually still something which is widely used for long distance or remote or at home, however you like to call this thing, long distance transmission of signals over internet or network or any sort of fiber long distance connectivity. But it's progressing, and we started actually building in something which was actually called JPEG XS, even so that the standard was not defined at that time. So Intopix, so the development guys behind this whole story, they are living or doing all of the research in Belgium. So we've got a good connection with them already over the years. And we started with an early adoption of using TICO, or then a predecessor of JPEG XS, even on baseband. So our first consideration was, hey, why not making 4K distribution on a BNC cable, on a regular physical 3G BNC cable? But back in the days, we were just simply too early. The whole industry said, no, 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 it has to be uncompressed. It has to be uncompressed. So we pulled it all out and we put JPEG XS in for IP signal distribution, but there are different flavors of JPEG XS out there. And that is actually that's why I'm saying we are on a journey. So we started with JPEG XS. Now there is actually a VSF TR08, and that is actually the description of JPEG XS in a 2110 environment. So 2110-22 equals TR08, either a 2017 or a 2018 revision, or 2020 revision. I need to look this up. So these are the nitty-gritty details which I always need to look up. You can't get them all in your head. So, and what you need to do is to stay on the forefront to actually be able to measure all of that kind of stuff. And that's one of the beauties of your device, because I never run into the challenge till today that your device is unsupported. So that's a beauty. So far, whatever we tried, any interoperability test we were running at, we've seen that your R&D guys actually try to stay ahead of the game equally to us. So the other thing, which is also interesting, is when it comes to any sort of cloud production. I personally don't like this word cloud production too much. Let's say distributed production. So every customer have a different opinion and approach to this, but you can have all sorts of streams, NDI, SRT, RIST streams, and they're all compressed to a degree. And here comes latency again. So another one is actually something which is on the horizon, especially for this type of application, which is VSF TR07, which is actually based on a 2022-2 stream, originally an MPEG transport stream, but now actually with JPEG XS inside. So actually making the ability, or having the ability to transport JPEG XS compressed streams without having a PTP source on all sides to be entirely synchronized, to have a transport stream rather than an asset baseband. Baseband is the wrong word. Well, a data stream which needs to be synchronized with PTP clock locally and centralized, right? So this is another thing which is on the horizon, which we are looking into. So our M solution, for instance, is taking these streams, for instance, already. On the camera side, we're looking into this. So there are a couple of interesting things which you should join us on NAB, which we can share there. So it's a little teaser. So in 4 weeks, come along, join our friends at LIDA and come along to us. We have a couple of interesting things also related to the different flavors of JPEG XS.
So Steve, is it going back? We just mentioned their MPEG transport streams, that again, we're starting off from the point that we're comfortable.
Yes.
It's the technology we know.
Yes. So, and MPEG transport streams are self-clocking. They don't rely on a synchronous transport. Everything's clocked at the receiver and dealing with PCR rather than PTP for any synchronization within the stream itself.
So my feeling is, talking to people, that I think there's a lot of interest in this, because you know, that move is just one step too big for some people to go remote, JPEG XS, PTP at both ends. There are just too many unknowns. Would you agree with that, Kevin?
Generally, it's becoming more easy. That was really a big challenge in the early days. So a distributed PTP synchronization with GPS receivers on both sides and grandmasters, or a distributed PTP is not too much of a challenge anymore when it comes to a big production. But when you think about multiple smaller productions, or actually just having, let's say, 2 or 3 cameras on one side and 1 or 2 cameras on another side, and 1 or 2 other sources, don't have to be cameras, somewhere, and you just want to get them all in the highest possible quality streamed towards your central production site, then a distribution of PTP is a brainer. And then transport stream makes perfect sense, right? So large scale remote productions kind of deal with it today. But when it comes to multiple production sites or smaller production teams all over the world, hooking up their device to a 5G network and want to have some kind of signal distribution, or actually having somewhere a fiber connectivity and want to hook it up to a fiber signal, to some kind of a network connection, which you don't know if it's NTP, if there is even PTP, or you don't need to have a synchronized signal in brackets. You just transport it with all the accessory or additional bits and pieces you need alongside with it, including headers. So that's another neat feature of JPEG XS. JPEG XS supports headers, something we normally would call VPID in the baseband world, or we would call SDP in a 2110 world. In a JPEG XS transport stream, this kind of information is literally not existing. So the JPEG XS header also contains all of the base information of that stream, so that the receiver actually knows what kind of compression scheme is it, what kind of data do you expect, so how do you need to decode this whole thing, so what is it actually, what we should make out of it in the end, right? So that's part of the JPEG story as well. So that's the ease of implementation, which is on this graph as well.
Yeah, and well, within a normal remote production, a large scale, almost like what's behind you, the JPEG XS sitting in a 2110 is gorgeous because it can intermix with uncompressed 2110 because of the absolute low latency. And you could have feeds coming in maybe from the opposite side of the stadium and actually bring those over with JPEG XS and get a lot more cameras on the pipe that you happen to have from one side of the stadium to the other. Even if it is dark fiber, there still is bandwidth limits. And turn around and intermix cameras coming in that are 2110, cameras coming in that are JPEG XS 22, and the switcher will take it and deal with it and have absolutely, the DP sitting there trying to do the production will never know the difference.
At least that's the ultimate goal at the end of the day.
Yeah. Yeah.
Yes. So it's kind of bringing us back to the question of which devices, which products does actually support the whole thing. So having, let's say, a camera which does JPEG XS going nowhere. So you need to have production switches, you need to have glue, which actually does the transition between compressed, uncompressed. There are multiple vendors out there who actually support JPEG XS right now. It becomes the de facto standard. In the very beginning, -22, which just meant compressed content in a 2110 environment, was like a big question mark. So where is the industry heading? Is it this compression scheme? Is it that compression scheme? Which one will we finally choose? And it kind of, we all polished our crystal ball and tried to figure out what's the thing we need to put in. And we polished it more and more, and we couldn't find a real answer to this. So I think because of this slide deck or this graph you actually have shown, it ticks so many boxes. At the end of the day, JPEG XS is the obvious choice. Is it the best choice in 10 years? Probably not. But at this moment in time, it's perfectly fine. And it can be adapted to many products. Yeah. And that's what more and more vendors are actually doing.
Yeah. I mean, it's, you look at, any of the stuff, the transition from HD to 4K and all the rest of the transitions. It's just going to fall in line that as things move on. Yeah. But I think for the next 10 years, maybe not 10, but for the next 5 years or so, JPEG XS is going to survive and really help.
We see we have so many conversations with so many broadcasters out there, and they have one huge challenge. They have a stiff competition. They need to produce more and more content. They need to produce this more and more content in high quality because of the stiff competition. And generally they get less and less budget for it. So the budget is not growing equally to the more amount of content they need to produce. So all of our customers generally need to be more agile. They need to be flexible. They need to have not an entire OB truck on the road traveling for 2 weeks or 2 days from one to the next production. They need to throw their stuff in a smaller van and actually drive to a production site and have their central facilities and just take the streams from here, and 2 hours later within the same control room they're doing the next production, and then 2 hours later they're doing the third or the fourth production from the same control room. So quality of production's going up because the equipment in that one control room can be higher in quality. So instead of buying 20 mixers, 20 routers, 20 intercom systems, you probably do only 3 or 4. So you can spend more money on good products, and you have a team which is working in a centralized production facility. Everything is known. It's not, I'm going on this truck, the router is differently configured, the intercom doesn't work the way I'm normally working. So this is always the same. So the quality, the viewing experience, the measurement tools in that facilities, they are all calibrated, they are all up to speed. So customers can do much more with their equipment. And the only big roadblock in this whole story is, how do we get proper content in good quality transported so that we do have as minimal staff on site, as minimal, rack equipment on site to do racking, to do all of the production centralized. And the only compression scheme I really see, with a few exceptions, and when you really justify, quality and you go with lower latency, higher latency, so you're kind of losing the possibility to do high quality productions like a demanding sports production outdoor, where you need to do camera controls rather quickly. You need to adapt to the ever-changing weather conditions. JPEG XS is the only solution out there we see. And that's why the Dash 22 with this big question mark on top disappeared, and out of this cloud, out of this smoke, JPEG XS is the only thing which stands out there right now. So there's literally no other compression scheme I see on the horizon at this moment for this application. Yeah. When you say, I just want to have a 20 megabit signal and I can live with a few hundred milliseconds of latency, hey, you've got all sorts of other things. But then please do not argue and complain that you do have this latency and you are not live anymore, or you have different transmission and distribution channels where you can see the goal, while here you're still waiting for the thing to happen, right? So,
well, and then you get into the chat and the delay when someone asks someone out in the field a question.
absolutely.
And it's,
so,
almost several seconds by the time it goes both ways. And
so that is actually an interesting one. So one of our customers, NEP in the Netherlands, they actually used LDX 150s in a bigger sports event in China some while ago. It was a very big sports event, and the Dutch people are really into ice skating. So this is a big thing in Netherlands. So they had specific requirements to have unilateral cameras, but they did the entire production from Hilversum in Amsterdam. So, and because of COVID, it was very, very difficult to get the right amount of people in. And so this kind of challenges drove you know, the development of the technology. So they finally actually did the presenter, you know, communication and interaction with less than or roughly 200 milliseconds in total. And you need to consider this is, you know, almost one time around the globe, right? So 9,000 kilometers by plane, but there is no fiber connection, which is going direct from Amsterdam to Beijing, right?
Yeah.
So when you consider all of this, and that would not be possible if you would not use this kind of compression schemes and data reduction.
Yes.
Very low latency, yeah.
I think the great thing with JPEG XS, that go back a couple of years and it was sort of an a la carte menu. You had one manufacturer did this, one manufacturer did that, one did that. Now broadcasters have a choice. There are multiple manufacturers out there with tools, you know, that maybe you have an operating preference for. So, you know, as I said, we're 4 weeks off a certain major trade show in Las Vegas, and I think we're going to see a lot of new products, a lot of innovative workflows. I mean, we've touched on it here. We've talked about remote production. We've talked about it going into the cloud as well, and that's a whole subject for another day. What I'd like to do is just before we start taking some questions from everybody, we have a third question for everybody out there, and it's sort of a bit of a wrap-up question. So, Catherine, if you're able to bring up the last question. So, from what you've heard today in our discussions, do you consider JPEG X as a replacement for 2110-20? Yes, no, it complements it, or you're still not quite sure?
I think I should actually take this question with me in our conversations we have with with clients.
Yeah.
As I said, one of the things I discover in all of the conversations I get involved with when it comes to IP integration and migration to IP 2110 or 2110-22, technically we wanted to tick the box to have uncompressed signal distribution, but for what? At the end of the day, it's going somewhere compressed.
Yeah.
And the port utilization and the amount of money you need to put into switch infrastructure, when you go with roughly 10 times less, you know, bandwidth requirements, you can still have a nice overhead so that that you are able to accommodate some peak production requirements, but with a much tighter budget.
Yes.
And that is something which a lot of customers really see right now as the right time to start the migration and to move forward with 2110. They call it 2110, but what they actually mean is mainly 22.
Yeah.
Right.
And I personally, I think I agree 100% with the outcome of that poll question. I think in today's market, JPEG XS is a beautiful complement to -20.
Yeah.
Replacement, I don't think everybody's quite there yet. But I mean, for, like you said, for remote productions, any place where you gotta, you know, transmit the signal, when you can get the signal down to, you know, 400, 800 megabits, and it is visually lossless, and your latency isn't really increasing with the compression ratio to where it's outrageous and you can't see it. And like I said, you know, stop by the grass booth, stop by the leader booth, and it's amazing when you see it on the waveform monitor and you see the native SDI signal going into a 2110 gateway. You don't see a difference between those two because it's like less than a line to do that compression, not compression, but do that wrapping, that gateway function. And then you take that 2110, convert it into JPEG XS. And if you can see 17 lines of delay when you're switching from, you know, scene to scene to scene, you're in the wrong business.
Don't tell this to the audio guys. They can sometimes see 20 milliseconds or 16.
They can
So,
hear it, they can't see it. There's a
So Cindy,
difference.
I realise we're approaching the top of the hour here. So I see we have got some questions. Would you like to fire them across to us? So obviously, thank you everybody for participating in the poll. That was our kind of litmus paper test on where the industry is at the moment.
Yes, so many good questions. One of them is the leader implementation of JPEG XS profile specific? There are non-into-pix variants that are seeking SMPTE approval.
So far, everything I've tested it with, I can't answer that exact direct, but I think Kevin Heiden can agree with me. Every camera that I have put it on from every vendor and every gateway we have put it on, if it didn't work, there was actually an error in the gateway. Everything we've put it on today within 2110-22 has worked perfectly.
Good to know.
That's how I can answer that.
Good to know. And if we have additional information on your questions, we'll circle back to you offline with that. And if we don't get to your question, don't worry, we will come back to you through email or phone call as well.
On that particular one, I would like to add one additional thing. We have a couple of different products within Grass Valley who actually supports JPEG XS right now, or 2022 or 2110-22. And whoever put this up, thank you very much indeed. And
you're welcome.
Yeah, so you can see we've put it into our cameras right from the camera as a native JPEG XS stream 2110-22 TR08. That actually can be received directly from our switchers. So the switchers have the ability, each and every single input stream on IP, on all of the IP inputs, can be either compressed or uncompressed. And the switcher can also actually spits out multiple variants, so uncompressed and compressed program signals, for instance. On top, there is the XIP card, which takes different variants of signals, including JPEG XS, and compress it or uncompress it. And there is a monitoring thing on the right-hand side, the IP view, which actually takes JPEG XS streams and you can directly put it on a monitor. So if you need monitoring to show this kind of JPEG XS streams or uncompressed IP streams, there are solutions out there. However, there are some new kits on the block next to JPEG XS. And as Cindy actually rightly read, seeking for approval. And I think this is always a chicken and egg problem. So yes, we can try to accommodate all sorts of different things, but what we need to see is that the industry is looking for a common standard, because the only thing we have more than enough already is hundreds of different things and different standards. So one of the other leader events in the past was about HDR. Yeah, so when you talk about HDR, you've got different standards. We're talking about different color spaces. There is ITP, there is 2020. We've got all sorts of different IP stuff. In the audio world, you've got different standards with different levels and different timings. And yeah, if someone is seeking for, and I'm only talking about the Grass Valley part of it, I can't speak for leader, obviously, but I think when it becomes reasonable, from what I understand from our company, what I understand from when I'm playing with a leader product is they're on it when it becomes interesting.
Yeah.
I think that's the best answer you can give, right?
Well, when it becomes a actual standard that everybody is following, we're not going to jump on something we can't. I mean, we aren't selling millions and millions of these things, so we have to be very careful that what we produce has a standard behind it, so it's now interoperable. I don't have to have the same transmitter and the same receiver. They can be from different manufacturers, and they work absolutely perfect.
Yeah.
It's they've
Oh yeah.
kept that.
SFPs.
Oh, yes.
Yeah.
No, so outstanding. I think this was very, very good session today. We hit on a lot of things. We want to really, really thank you, Kevin, for.
Was that the only question, Cindy?
We do have more questions, and we can do a couple more, or we can circle back to everybody offline. Steve,
Let's
Kevin?
go ahead and do another one.
Well, there's one popped up here speaking about audio, but obviously we're talking about compressed video only.
Yeah. We will address every single question offline that we don't get to here. And the appropriate party, either on the leader side, leader fabric side, or the Grass Valley side, will answer everybody's questions. But go ahead, Cindy. Throw another one at us.
All right. I kind of like this one. What can we expect when we produce using JPEG XS and distribute using MPEG?
No issue whatsoever. Primarily because of JPEG XS being wavelet in nature, it doesn't have the boundaries of the pixel blocks that are in MPEG. And that's kind of what you get in when you overdo MPEG compression, is you end up compressing and introducing some of the errors from previous links that aren't on your boundaries. So now you add another block boundary where errors can actually happen, because they actually happen on block boundaries, and it's not a block-based DCT type compression. So that's one of the reasons it can be compressed and decompressed 10 times without any negative impact visually, is because of it being wavelet based.
And you talked about timing and reference and clock during the session a little bit. We did have a question asking, what standard does JPEG XS expect?
Depends on the transport. So if it's in 2110, it's going to be PTP. If it's in a transport stream, it's going to be like any other transmission within a transport stream. You're probably going to put it into something and frame reclock it to your house source on reception so that it is in time with house. If it doesn't have to be processed, yes, you can pass it through, but it will not be in time completely with your house. But in most cases, if it's going to a distribution center that's redistributing it, you'll probably put it into a frame store, reclock it so it's in time with your house.
Nice. I think we can leave it there and come back to the others offline, unless any of the hosts, if you see something you'd like to dig into, we can call it good.
There was one there.
Kevin,
I'm
go
probably
for
going to
it.
get shot for doing this one. So I had a question. Is the JPEG essence coupled directly to 2110, or is it decompressed into a gateway prior to entering the media fabric?
At source, well, let's say with the LDX 100 series cameras, it's converted right off of their processing to JPEG XS, and it starts out at JPEG XS, gets wrapped in 2110, if you will, and is transported straight through as 2110, stays 2110 or stays as JPEG XS till you process it and view it. It isn't, there is no course in or out multiple times. So it isn't put into a gateway, brought back to baseband, brought back to 22, brought back to every time you hit an SFP. You hit a switch, you hit a processing device, it's 2110-22.
It's really the question, if you got a compression decompression engine that actually takes this 2110-22 or JPEG XS stream as transport stream and put it either into a baseband signal or put it into a 2110-20 stream. If that signal hits the device, like on the switcher side, it is directly put back into parallel bit values and actually get processed as regular in brackets video, right?
Yes.
So you
Yeah,
don't
you
need
gotta-
to cycle through different types of signal space. That's impossible. It's not necessary at all.
Yeah. Yeah, and if you're going to put it into, one of the K-frame production switchers and you have 2110 uncompressed, yes, you are going to have to decompress the XS, and the switcher is going to deal with it, as Kevin said, as pure bits.
Correct.
And do what it needs to do at a baseband level, because anytime you pull in keys, you pull in all the effects, everything else you need to do, you got to do that at the bit level and be able to put that back out the door. But that's the beauty of JPEG XS. You're not really adding any more latency. You're not adding any more artifacts in doing that.
Excellent. Well, Steve and Kevin, thank you once again. It's been a very open and honest discussion about a subject that I think we'll be revisiting as we go forward. As we mentioned, if you're attending NAB 2024 in Las Vegas next month, on the leader booth, and we're in the Central Hall, 5521, and Grass Valley also in the same Central Hall, 2308. We'll be demonstrating JPEG XS workflows and analysis tools. And so if you're attending the show, please don't hesitate to reach out to us, make an appointment, or if you've got any questions after this, Steve, Kevin, and myself, I think most of you have got our email addresses. Ping us a question and we'll do our best to answer it. So
We
Kevin,
certainly will.
thank you once again.
Thank
Yeah,
you, everybody. We appreciate it.
Yeah.
And Steve,
Also from my
thank you very
side,
much.
thank you very much.
Yeah, Kevin, thank you so much for joining us on this chat. I love it.
You're very
And we look
welcome. Thanks
forward
for
to
the
seeing you in
invitation.
Vegas and getting
Yeah.
our hands on some of this stuff. And
Yeah.
Steve,
See you
better
then.
you get back
See
to
you
putting
soon.
those cables around the stand.
Yeah. Take care, everybody.
Brilliant. Thank you very
Take care.
much, everybody, and have a good day out there.
Thank you. Bye.
Bye-bye.